So with our lines, we knew that two lines could meet, not at all, if they were what kind of lines? Parallel. We had some cases with infinite solutions. When did that happen? Yeah, when everything cancels out and we were left with the true statement, which in terms of the graph meant they were the same line. Otherwise, two lines could only meet at one point, correct? But if I'm talking about a system of nonlinear equations, so let's say I gave you a parabola and a line. How many times could a parabola and a line meet? They could meet twice. I looked at something like this. Is there any other option? Could they meet once? If I had something maybe like this. Is it possible to have a parabola and a line that don't meet? Yeah. So if I have nonlinear systems, there's not necessarily a rule of how many times they meet. It depends on what the graphs are. You know, if I gave you a circle and a parabola, they might meet as many as 4 times. So we can't just look for a single answer. But our strategies are going to be the same. We're going to use substitution and elimination. So let's take a look at this one. If I want to solve this, do you want to try substitution or elimination? Substitution. So what would be best to substitute, do you think? Take the bottom one and get what by itself? Maybe the y. Because ultimately, I want an equation that has both x squared and x in it. That I could solve. But can I solve an equation that has an x and a y in it? No. So the y is the odd thing. That's what I'm going to try to get rid of. So I'm going to say y is 1 minus x. And I'm going to sub that into the first one. So yes, x squared plus 1 minus x equals 7. So bring over my 7. And solve. What multiplies to a negative 6 and adds to negative 1? So if I set those equal to 0, I get 3 and negative 2. Now, that is not an ordered pair. What that is, it tells me there are 2 points. In one of them, the x is 3, and one, the x is negative 2. So I have to find the y for each of those. So when x is 3, you know y is 1 minus x, so y is negative 2. When x is negative 2, y is 1 minus negative 2, so y is 3. And you can check them. 3 squared is 9, plus negative 2 is 7, 3 plus negative 2 is 1. Negative 2 squared is 4, plus 3 is 7, negative 2 plus 3 is 1. So strategies are the same. You can substitute or eliminate, but we don't necessarily know how many answers we're going to get at the end. Is that one okay? Substitution, elimination. What do you want to do? elimination. That is actually pretty nice. If we go ahead and just add these together, x squared plus 2x squared is 3x squared. Y squared plus negative y squared cancels. 4 plus 8 is 12. So x squared equals 4. Square root plus or minus. So x is plus or minus 2. All right, that's 2 different points. So to get y, I have to put each of those points back in. So if I put in 2 to the first one. I get y squared equals 0, which means y is 0. Square root of 0 is 0. What's going to happen when I put in negative 2? Negative 2 squared is still 4. Still get y squared equals 0, and square root of 0 is still 0. So I got 2 answers. 2, 0, and negative 2, 0. Real quick, what if I had plugged in 2 and I solved it and got y to be plus or minus 1? What do you think that would mean? You would actually have 2 points from that. You would have one when x is 2 and y is 1, and one when x is 2 and y is negative 1. So if you plug in a number and you get a plus and minus, that's 2 ordered pairs that it's giving you. All right. Is that one okay? Let's look at this beautiful problem. I think I kind of meant to change this problem and I forgot. Can I give you a different one instead? Would you guys mind that? It's using the same strategy, but it just looks a little different. What would you have to do here? Does anything, can I eliminate? No, because I have an x and a y and I have an xy. So I have to do substitution. You can solve for either one. Let's say I took the first equation and I solved for x. That means x would be negative 20 over y. And I'm going to plug that into my second one. So I replace my x. What do you think I could do here? Yeah, let's take everything times a y. So if I put everything on one side, this is 3y squared minus 7y minus 40 equals 0. So what do we do from there? We need to factor that. So slip and slide. If you multiply your 3 down, then we get y squared minus 7y minus 40. So we need, or sorry, mine's 120. We need things that multiply to a negative 120. Divide our 3 back. So we get y minus 5. Or y plus 8. Flip those to 0, so we get y equals 5 and negative 8/3. All right, we have to get x. We know x is negative 20 divided by y. So negative 20 divided by 5 is negative 4. So negative 4, 5 is one of my points. This one. So negative 20 divided by negative 8/3. 15/2. Are we okay with that one? I want to do one more together and then I'm going to have you guys try one. All right. Elimination is probably not going to work because I don't have the same powers. You know, we have x squared and y squared down here. It's absolute value of x and y. What I would recommend is solve for the absolute value of x. What does absolute value do? Makes it positive. Okay. So think about, like, if I said x was 3. The absolute value of x is still 3, right? And 3 squared is 9. If x was negative 3, what's the absolute value of negative 3? 3. And when you square it, you get 9. So x squared is going to be the same thing as the absolute value of x squared. When you square it, it becomes positive anyway. So whether you make it positive before you square it or not, it won't change anything. So what I can do, since this is squared, I can actually replace my x with my absolute value of x. So I can sub that into the first one, so 4 minus y squared plus y squared equals 16. To square the 4 minus y, we have to write it twice in FOIL, so we get 16 minus 8y plus y squared. Combine like terms, y squared plus y squared is 2y squared. Minus 8y. If I subtract my 16 over, what happens? Cancels out. So take out a 2y, y minus 4, so y is 0 or 4. All Alright, if I'm going to find x, I have to do the absolute value. You can plug it into either equation, so if you weren't comfortable solving an absolute value equation, you could always put it back into the quadratic. If the absolute value of x is 4, then what can x be? What numbers have an absolute value of 4? 4 and negative. So I got two answers, 4, 0, and negative 4, 0. If y is 4, the absolute value of x is 4 minus 4, which is 0. What number has an absolute value of 0? 0, and that's the only one. So I got 3 answers that time. Why don't you guys try? Either x squared or y squared, so which one did you guys go with? Okay, so you took the everything times negative 3. You can go either route. If you eliminated the x squared, you would have multiplied by negative 4. So if I add those together, I get x squared equals negative 4. So when you do that, you have square root plus and minus. What is the square root of negative 4? 2i. Okay. So if I do that, I have to come back and plug it in. So if x is 2i, put it in the first one. We have 2i squared plus y squared equals 5. 2i squared is negative 4. So y squared is 9. Square root plus and minus. So I get positive and negative 3. So that means when x is 2i, y could be 3. Or when x is 2i, y could be negative 3. What happens if I put in a negative 2i? What's negative 2i squared? It's positive 4i squared, which is negative 4. So if I add that over, y squared is 9. Square root plus and minus, and we get plus and minus 3 again. So negative 2i and 3, and negative 2i and negative 3. So it's okay if you get an I. You might have multiple answers here. That's okay. Any questions? Okay. Then there is a handout posted on Classroom. That's your homework. If you don't have the Math Excel from yesterday done, you also need to finish that.